We're going to now look at the steps involved in estimating a simple linear regression cost function using Excel. And again, our linear cost function is the form of y equals a plus bx. There are two types of regression. Simple regression, and that estimates the relationship between our dependent variable, typically our cost we're trying to estimate, that's our y, and one independent variable, and that's the x. And the second type is multiple linear regression, where we're going to estimate our cost as a function of two or more independent or x variables. We're going to begin by looking at our simple linear regression model. We've got a set of data, and we're going to try to estimate our indirect manufacturing labor cost, our y variable, by looking at machine hours as our independent variable. So we're going to begin by focusing on these two data sets. First thing we're going to want to do is prepare a scatter plot. In order to do that, we want to highlight the independent variables, and if we hold down the control key and then highlight the dependent or y variables, then we can go up to our main menu in Excel, Insert, and we're going to insert a scatter graph. Once we've inserted our chart, we can then fit a line to our data. We're going to add a trend line. And if you go to the data points and you right click, you'll see an option here for add a trend line. And we could add exponential, linear, logarithmic, polynomial, power, or moving average trend lines. We're dealing with linear regression, so we want a linear trend line. And we want to display the equation on the chart and also our r squared, and we'll talk about our r squared here in a second. Then we hit close, and let's just left click on that, and we can drag it to the side just to get a little bit better viewing of what our cost equation is and our r squared. Our cost equation is y equals 10.31x. This means that for every 1 hour of machine hours that we're running in our factory, we're going to expect to incur roughly $10.31 in indirect manufacturing labor cost. And our fixed component, or our y-intercept, is roughly $300. Our regression is explaining, we have an r-square of 52%. That means we're explaining roughly 52% of the variability in manufacturing costs by looking at changes in machine hours. Let's try to get a little bit better idea of what that r-square means by changing one of our data points. Let's take this 60 machine hours and let's change that, instead of 60, let's make it 10. And we can see now that our r-square has gone down. There's a little bit less explanatory power, where before we were explaining 52%. The points are fairly closely scattered along the line. But if we change that 60 to 10 hours, then our r-square goes down to 50%. Again, the distance that these points are on average from our trend line have increased. If we were to make this 1 machine hour, we can see our r-square, or the explanatory power of our regression, has decreased even more. Now we're only explaining 47% of the variability in our costs by looking at changes in our machine hours. So let's go ahead and put that back at 60 where it was. In addition to putting together a scatter graph and adding a trend line to it, another way we can estimate our regression is using Excel's data analysis tools. Our data analysis tools are up here on the Data tab, and we can come over to here to Data Analysis. Now, if you don't see this on your Data tab, what you're going to need to do is add the add-in for the Data Analysis Toolpak. To do that, we would go to the Office button. We would come down here to Excel Options, and we have a choice for add-ins, and we would select Analysis Toolpak. We would come down here at the bottom and hit Go. We would select the one we want, at least at a minimum, is the Analysis Toolpak, and we would hit OK. And once we've done that, you will have added your Toolpak to Excel, and when you go to your data menu up here, you should see Data Analysis. We want to run a regression. So scroll down, we're going to find our regression, hit OK. Our Y or input range, again, we're trying to estimate our cost. We can highlight our costs. We're trying to estimate it using our machine hours. Our output range, let's just put that, let's have it on a new worksheet ply. Or actually, we'll just put it down here, down below, maybe on cell B19 will be our output range. And actually, I've got to pick up my data again. I screwed that up. Let's come down here. Our output range is going to be cell B19. And we're just going to go ahead and hit OK. Now, if we come down and look at our output, one of the things we can notice, I'm just going to grab and drag this graph down a little bit also so we can compare our outputs. First, our R-square, there's the 52% that we got with our trend line. Our coefficients, our y-intercept, 300. That's what we had on our trend line. Our x-intercept, or our coefficient for our slope for our x variable, 10.31. That's what we had there. So for a simple linear regression, we can either use our scatter plot and add a trend line, or we can run a linear regression output. Let's go ahead and move our data back up top. And let's consider running a second simple linear regression. In this case, we're going to use direct manufacturing labor hours. And we're going to use that to try to, again, explain our change in labor costs. I've highlighted my data, insert, scatter. There's my scatter diagram. I'm going to just move this down here a bit. I'm going to, again, right-click, add a trend line. I want to display the equation on the chart, display the R-square. I hit close. I'm going to move this right over here. And notice, this only has an R-square of 16%. So it's not doing nearly as good a job in explaining the variations in cost. So direct manufacturing labor hours don't seem to have a lot of explanatory value in explaining our indirect labor manufacturing costs, which might make sense because probably our indirect laborers are operating our machines while our direct labor manufacturers are actually working on a product on a hands-on basis. But we have a very poor explanatory power for this regression. So if we had to choose between whether we wanted to use direct labor hours to predict manufacturing costs, indirect labor manufacturing costs, or machine hours with the higher R-square gives us better explanatory ability. Again, if we wanted to run a linear regression using Excel's regression output, and we're going to particularly want to do this when we have multiple linear regression, we would go to Data, Data Analysis, Regression, Output Range. That's not changing, but this time in terms of our inputs, instead of using our machine hours, we're using our direct labor hours. In terms of my output range, instead of overwriting what I have there right now, I'll put the other one down below here at cell B40 and hit OK. And again, there's our 16% R squared, and our coefficients are agreeing with what we had for our trend lines. One thing I should point out really quickly, again, when we changed our data point from 60 to 10, our charts changed, our coefficients changed, and our R-squares changed on our chart. But notice, the regression output, this is printed output. It is not linked by formula to our input field. So once we run it, it stays static or the same. It will not change. It's still at the 52%, and our coefficients were still 310, where on an equation here they've changed from 6.8 and 577. So again, if we look at our charts, they are dynamic, but our regression output is static. So let's put that back at 60 for now. Another way we can get our y-intercept and our slope are using some of Excel's functions. Let's go ahead and invoke our function wizard. We're going to pick the category that is statistical, and under statistical let's come down till we find, here we go, intercept. We'll hit OK. Our known y's, well, our y's, that again we're trying to predict our cost based on machine hours. Let's hit OK, and there's my intercept. There's also an Excel function for the slope. fx, statistical. Let's come down to slope. OK. My known y's, again I'm trying to predict the cost using machine hours. I'll hit OK, and there is my slope. And finally I can also calculate my r-square. fx r-square, OK. Again, I'm predicting my known y's or costs using my machine hours, and there's my r-square. And again, the significance of our r-square is we're basically saying that machine hours are explaining roughly 52% of the variability in our indirect manufacturing labor cost. And again, we compared that to using our direct labor hours, which only had an explanatory power of roughly 17%. Something else we're going to look at a little bit more when we do our multiple linear regression is if we look at the t-statistic. When we were using our machine hours, we had a t-stat of 3.3. There's about 1% probability that this is just by chance, but 99% chance that there really is a strong relationship here. When we compare that with our t-statistic for direct labor hours, only a 1.14, there's some relationship there, but there's an 18% probability that this is just pure chance and there's really no relationship at all. So given a choice between two variables, we'll typically take the one that has the higher t-statistic because again, it gives us greater explanatory power. We're going to go ahead now on the next tab in the next lecture series, look at multiple linear regression.